I'd like to introduce our next remote speaker, Pierre Ricadat, aka Ghost Dog PR. Pierre was an early ZIO contributor and has gone on to be the author of Caliban, which I think, as you heard from Alex, who would know, is, I think, the best GraphQL library around. And he's also built an amazing community of contributors around this. So he is so nice that he's going to be speaking twice. He's going to be speaking to us once about building beautiful domain models. And I think ZPURE may fit in there. And then he's going to be speaking to us again about the latest developments in Caliban. So we're going to see how the best GraphQL solution is getting even better. But with that, I'll hand it over to him.
Okay, so today I'm going to talk about our quest for writing beautiful domain logic. You might see a lot of common parts with Jorge Vasquez's talk earlier, but this is more from the perspective of a production large project. So this should be interesting. So yeah, I am Pierre. I'm talking to you from Seoul, South Korea. You might have seen my avatar in the ZIO Discord or on some of the ZIO libraries in the ecosystem. I work at a company called DEVSISTERS, that is a Korean gaming company. And we launched a mobile game called COOKIERUN Kingdom in January of last year. This game became quickly very successful with over 40 million downloads so far. And all the game servers are entirely written in Scala and even purely functional Scala using ZIO and many of the libraries of the ecosystem. So I wanted to share a little bit of a success story of ZIO. Okay, so just to give you some context, this is very simplified how our architecture looks like. I don't have time to explain it in details, but the two important keywords are CQRS and event sourcing. So when we receive commands from the client, we forward them to an entity. So an entity can be, for example, a user or a guild. And a single entity exists only in one place across our cluster at any given time, and it processes the commands for that entity. And then it generates events that we store in an event store, and then we forward them to Kafka for further processing and projections, creation, and so on. So today I'm going to focus on the domain logic part of the system, which is the orange circle there. So our domain logic has two kind of flavors. There is first what we call transitions, that is taking a state and applying an event to get a new state. So that's something we run, for example, when we load an entity, we take the latest snapshot of a state we have from the database, and then we replay events to get to the current state. We also run transition when we create new events to get the new state instantly. And then we have what we call programs. So program takes the current state and then a command and generate new events. And when we generate those new events, we also apply transitions for those events and get a new state. So I'm going to focus on programs now. So our programs also have more constraints. They might need to return a result to the client. They might fail with a domain error. We validate what the client sent to us, and if it doesn't make sense, we want to fail. And it might require some configuration variables. In our case, we have a lot of different game rules and constants, so a kind of environment. Another constraint that we have is that we don't want side effects in this part of the code. Why? First, because as I said before, we replay those events in the transitions. So when we load an entity, we don't want to call side effects just by loading the entity. Another reason is that when there is a validation error, we don't want to do anything. So if there was a side effect that happened before the error, that's a problem. So we don't want that. And even across multiple entities, we have the concept of transaction. So even if something is successful in one entity, but fails in another entity that is part of the same transaction, we still don't want to do anything. So it's very important that we don't run side effects in this part of the code. If we want to run side effects, we do it after persistence as a kind of response to the event being triggered. And finally, it needs to be fast. So our domain logic can get pretty complex because whenever a player does an action in the game, we have hundreds of quest requirements, missions, items that could be unlocked. There are a lot of things that we need to check. So we even measure that the CPU time spent by our game servers was over 50% just for this business logic. So it's something that is often overlooked. People say, "Oh, but I/O will take more time." But in use case like ours, it's not the case. The business logic takes a very large amount of CPU power. Okay, so how do we implement a program? The very naive way would be to use a function from a tuple of environment, state, and a chunk of events to either an error or a new tuple of state, chunk of event, and a result A. And then we could use a monad instance from CATS, Scala Z, or ZIO-PRELUDE, and then use the flat map coming from this instance to write four comprehensions. However, it is not convenient to do four comprehensions on functions. That is not ergonomic at all. Flat map is also not stack safe for functions. And then at every flat map, you need to unlift this function, this either, and this tuple, and recreate a new one. I will show you an example of that after. So what about using a dedicated data type that is made for this purpose instead? So in CATS, there is something called indexed reader writer state T. That is like a richer version of state that was introduced in the previous talk. So it looks like it's made for our use case. The only thing that's missing is the error. So in order to have an error type, we need to use maybe either as our F. But the problem with this is that if you look at the underlying implementation, you see that it's actually an F of, again, a tuple, a function from a tuple to an F of another tuple. And when I was saying that you need to unlift and lift things, let's have a look at the flat map implementation. You see that when you do a simple flat map, you need to do a shift and then a map, a flat map, another flat map, a map, and a combine. Whatever you are doing in your flat map, you have to do all these operations. So you can guess that this is not going to be very efficient performance-wise. So what about using ZIO? We can use ZIO environment to put our configuration. We can put the state and our list of events inside the ref in the ZIO environment. And then we can use ZIO E and A parameters for the error and the return type. Performance-wise, that's great because it's just a single data type. There is nothing to unlift or lift because of the effect rotation technique that ZIO is using. However, the problem is that, again, this is too powerful. Our team has good discipline when it comes to not running any side effect outside of ZIO. We know that if we have to run a side effect, it needs to be wrapped in ZIO. But if the type is ZIO everywhere, then what prevents us from just coding something that does some side effect? The temptation is really high. And even though we say we should not do it in this part of the code, we might miss it in code reviews because the type align and it's not going to be shocking. So ideally, we need something that is a bit less powerful. One option is using CATS-MTL. So CATS-MTL is a bunch of type classes, or a bunch of interface, basically, that expose only some features. So we have monad error, ask, stateful, and tell. So they only allow us to raise an error, read the environment, write events. They don't let us run some effect if we only use those, because we don't know what the F actually is. We can use ZIO as an F behind the scenes, but we don't have access to ZIO.effect or fork or these other functions that are too powerful. So this is a good idea on paper. However, in practice, the type inference is really not great. We often have to we get cryptic errors and we have to manually enter type parameters. Everything relies on implicit, so there is some boilerplate involved, and methods are less discoverable because you need the proper import in order to see it. And it's also not convenient to deal with errors because monad error is invariant in its error type. So you can't easily eliminate or change the error type. So I guess you know what my next slide is going to be. Yes, ZPURE. So ZPURE is really the perfect solution for our use case because it combines the good performance, having a single data type, discoverability because all the methods are easily accessible from the ZPURE objects, and it doesn't allow us to run effects. So we also ran some benchmark. Actually, our project went from the solution with the indexed reader writer state T to MTL plus ZIO to ZPURE across the last 2 years. And the last change from MTL plus ZIO to ZPURE was done after the product was already in production. So this benchmark that we did are just calling, reading the environment, lifting some event, modifying the state a bunch of times in a loop. And similarly to the previous benchmark, it's almost the same result. ZPURE is way, way faster. And as I said, this is not just a benchmark for the sake of a benchmark. We observed similar improvements in production when we did those replacements. So in practice, how do we work? We wrote a custom DSL for all the basic operations, such as getting the state, succeeding with a value, and so on. And then we build smaller function on top of it. And then we build all our business logic, assembling all those smaller functions. So we have this DSL is very simple. Just we have pure raise error, assert that, inspect for the state, inquire for the environment, lift event. And then we write functions like this. So we don't use ZPURE directly. We use type aliases to make the signatures smaller. So for example, we have a guild program. And then we have functions like these, inquire guild metadata, inquire requester ID, using those primitive operations. At the end of the day, all our business logic, all our domain logic looks like this. So we have a simple program here that gets some metadata, some user information, check the state, verify that the request is valid based on the requirement, and lift some event. And lifting the event is going to trigger the transition that also modifies the state. So why is this beautiful? Why do we call this a beautiful domain logic? First, there is zero noise. Like if you look at this, there is no technical concerns here. It's only about our domain logic. It's easy to read, it's easy to maintain. If there is a newcomer in our project, he is able to read that code and start writing such code as long as they understand our domain. Another thing that is nice is that it is independent from the program implementation because we used our custom DSL on top of ZPURE, but before it was on top of ZIO plus MTL. When we switch, we didn't need to change everything. And finally, it is really fast, and fast is beautiful in this case. All right, thank you so much. This is the end of my first talk. I'll take any question. Maybe we don't do question because these are...
Yeah, I think no
talks.
questions. Questions on Discord.
Okay. I will answer later, and I will just switch to the second talk. 2 for the price of 1. All right. Can you see the new slide?
We're ready for Caliban.
Okay, perfect. So yeah, well, this talk, in this talk, I will talk about what's new in Caliban. You know me by now. Okay, so if you don't know Caliban, Caliban is a library, a Scala library for writing GraphQL clients and servers. It was originally created in October 2019 and presented at the first edition of Functional Scala that year. A few months after that, Caliban client was created. The first version only had the server part. And then other milestones are Scala-free supports that happen ahead of the official Scala-free release. And we also released the 1.0 in June last year and reached 100% spec compliance in October. The library actually was 95% or more compliant. Way before that, there was only 3 validation rules that were quite tricky to implement that we were kind of pushing back, and we finally got to them in October. So now all the validation rules from the spec are implemented. So one of the things that was improved recently is about adapters. So adapters are thin layers on top of Caliban server core to make it super easy to use Caliban with the most popular HTTP server libraries. Initially, Caliban came with an HTTP4S adapter, and then contributors added adapters for Aka HTTP, for Play, and for ZIO-HTTP last year. But with this, a problem happened. That is, the maintenance burden became larger and larger. And because every time we added a feature, we had to implement it 4 times. And also, many contributors were adding a feature in the adapter that they were using at work and not in the other ones. And it became a little inconsistent. Like, as you can see, there are several features that were supported only in one of the adapter, or maybe 2, but not the others. So it was a bit confusing and quite a burden if we wanted to maintain it all the way. So the solution was to write a brand new adapter based on TAPIR. If you don't know TAPIR, check it out. It's a great library. Basically, TAPIR is doing is giving us a DSL to describe server HTTP endpoints, and then it has a bunch of backends that you can use to expose those APIs. So we are basically now offloading that work of compatibility to TAPIR, because that's the main goal of TAPIR, and not trying to do it on our side. So now there is a single adapter using TAPIR that has all the functionalities that were kind of dispatched between different adapters before. And you can use that TAPIR adapter with any backend that TAPIR supports. So there are many benefits to that. Now we have a single implementation. There is no duplication between 4 different adapters. The features are consistent. You can use it with any TAPIR server backend. So even if there is a new backend that comes up, you can use it directly. You don't even need to wait for Caliban to add any support. Same with the JSON backend. Before, historically, the Caliban adapters were fixed to a specific JSON library, but now you can easily use any JSON library. TAPIR also generates a HTTP client. So we were able to create a test suite using that client to test the TAPIR adapter with all the backends very easily. And it's easy to make your own. So as an example, the HTTP4S adapter in Caliban uses Circe as a JSON library. But if you don't want that, you can, in just 2 lines and 2 imports, directly use the TAPIR adapter and pass it the HTTP server backend and import the ZIO-JSON library, for example. But you can use play.json or whatever. And then this will just switch the JSON library that is used underneath. That's as easy as that. Okay, another cool thing, that was added in Caliban. Alexander already presented it very well before, so I don't need to explain about it too much. Just an interesting thing to know about it is that it was implemented without any change to Caliban. It's using a feature of Caliban that is called field metadata that basically gives you access to some metadata about the query. And using that feature only, we're able to extract the fields, the column names, and the filtering that QUILL needed to optimize the SQL query. So yeah, I have an example here. You have a GraphQL query where you want to filter to have just users or persons where the first name is Joe and you only want the ID, the last name, and the street. And then when you write your QUILL query, you add those 2 magical functions, filter colons and filter by keys. And colons and filters are coming directly from a helper from Caliban QUILL that uses Caliban metadata. So you get that for free, and that will do the filtering. All right. Another cool thing that was added is a laminar integration. If you follow Kit on Twitter or Twitch, you maybe know what's laminar already. This is a really cool framework for building front-end with Scala.js. So last year I added support for Laminar in Caliban to make it super easy to transform your GraphQL queries into event stream objects of Laminar that you can bind to your UI. So as an example here, you have a Caliban client query, queries.characters, and then you just call to event stream to transform it into a Laminar event stream so that you can directly bind it to your UI. It is especially powerful when using subscription because you can transform a subscription into an event stream. And when you bind it to your UI, whenever the subscription receives new element, they can appear in the UI directly. I personally use this at work for doing progress bars. I'm sending the progress through a subscription, and then I bind the progress to a UI, and the progress bar is moving magically. That is really cool. Still with Caliban client, something really cool that was added is about code generation. So it used to be possible to generate the client boilerplate using a GraphQL schema file or a URL. If you had a GraphQL server running, you could directly target that server and generate the client from it. But now you can also do it from the server code. So if you use Caliban on the client side and on the server side, you can generate the client from your server code. So this work was done by Gizmay, aka Jules. I'm very thankful for that. So it's just a little SBT configuration. You have a plugin that you enable on your API project and on your client project. And on the API project, you give the location of your GraphQL API together with some generation settings. And then on the client side, you just target your server project, your API project, and it will generate the client from that. That is really convenient if you use Caliban on both sides. Okay, something cool that recently came up, ZIO 2.0 support. So there is a Caliban 2.0 RC1 for ZIO 2.0 RC1, and now there is an RC2 as well for ZIO 2.0 RC2. It has all the features that the latest Caliban release has, 1.4. Except that ZIO and all of the dependencies are on ZIO 2. And there is more that I don't have time to present today, but we also recently added support for Apollo schema reporting, schema stitching. There is some relay support that was added as well recently, and a lot of things. The core is not moving that much. It's very stable, but there are a lot of support for plugins and so on that are added frequently. Okay, so before I finish, I just want to thank the two other maintainers of Caliban, Paul and Frederick. And we recently reached more than 100 contributors. So I thank all of them for their support and contributions. And thank you for listening. That is all for me.